Hello everyone, and let's go and do more limits involving hospital rule. But the next set of questions, we will have to do some algebraic preliminaries in order to transform our bad limits into bad quotients. So remember, hospital rule can only be applied if your bad limit is either 0 over 0 or infinity over infinity. For the other ones, we need to play with them. All right, so let's do our first bad product. So let's compute the limit as x goes to minus infinity of x times e to the power x. So as usual, the first thing you do when you have a limit in your face, okay, is you try it. So if you replace every single x by minus infinity, you get minus infinity times e to the power of minus infinity. E to the minus infinity is 0. Oh no, you get infinity times 0. So you cannot apply hospital rule. So what do you do when you have a bad product? Well, this is what you do. Boom. Okay, so for a bad product, what you have to do if you have infinity times 0 is you need to choose one of the two terms. Either you take your infinite and you flip it down. So you take your plus or minus infinity and you flip it down. So you take infinity or minus infinity and you bring it down as 1 over infinity. And then what you'll get is 0 over 1 over plus or minus infinity, which is 0 over 0. And that's a bad quotient. Or you can flip the 0. So if I change the color here, you can flip the 0 and bring it downstairs. Of course, normally you need to know what type of 0 you need in order to decide what type of infinity you get. But in general, when you flip a 0, what will happen is that you'll get plus or minus infinity over one of the zeros. So you'll get plus or minus infinity over infinity, which is a bad quotient. So remember here, the trick is fairly simple. It's a bit weird, but the idea is that if you have a product, A times B, you can bring B downstairs as 1 over B, or you can bring A downstairs as 1 over A. So A times B is the same thing as A over 1 over B, or B over 1 over A. So one of the two will work. So let's now play with R. And the big question, and this is like the difficult part with these bad products, is which term do you flip? And sadly here, there's not a lot of tips. There's one that we'll see in the next example, but in general, you try to flip the one that is the easier to bring down. So for example, if you have x times e to the power x, an exponential term is actually a term that is fairly easy to flip because you can always move an exponential term from up to below just by changing the sign of the exponent. So here, this is not hospital rule yet. It's just moving a term. So I'm going to bring ex downstairs and get the limit as x goes to minus infinity of x over e to the minus x. So I brought the ex down as e to the power minus x. So I'm not changing my expression. I'm just rewriting it. Why is this better? Well, if you replace x by minus infinity again, you're going to get minus infinity for the top. And for the bottom, you're going to get e to the minus infinity, which is infinity, minus infinity over e to the infinite, which is minus infinity over infinity. So this is still bad, but it's better bad. In case it's a bad quotient, so now you have the absolute green light to turn this limit using hospital rule. So if you differentiate x, you're going to get, so if you differentiate x, you're going to get 1. And if you differentiate ex, e to the minus x, you're going to get e to the minus x using a little chain rule here, times minus 1. And now if you plug in minus infinity, you get 1 over e to the minus infinity times minus 1, which is 1 over e to the infinite times minus 1, which is 1 over minus infinity. And any number over plus or minus infinity is 0. So for a bad product, you need to choose. Which one do you choose? That's not an easy question. You need to choose one of the two terms and flip it to recover a bad quotient. And once you have your bad quotient, you apply hospital rule. And you hope that with one application of the rule, you're going to get to your answer. All right, let's do another example. Very important example coming up. All right, the next example will be again a bad product. So suppose we want to compute the limit as x approaches 0 plus of the square root of x times ln of x. Of course, if you plug directly 0, you're going to get root of 0 times ln of 0, which is like two bad boundaries. So we need to plug 0 plus. So you get the root of 0 plus times ln of 0 plus. The root of 0 plus is okay, it's 0, and ln of 0 plus is also okay, it's minus infinity, but then you get the product of these two things, and that's why it's bad. But here, there's only one thing for sure that you're never going to get to flip, because when you have a product, you need to flip one of the two terms, and the only advice that will always work for the limits that we're going to study in this class is the following: never flip the logarithmic term. Of course, you could say, well, Bebe, if you have two logarithmic terms and they're multiplied, which one do you flip? And you said never flip a logarithmic term. Well, if you are doing a limit and both terms are logarithmic, it's because you're having a nightmare and you need to wake up. Okay, so you're not going to get those examples in this class. Okay, so if one of the two terms is a logarithmic term, you always flip the other one. So if we go back to our question now, again, and the two terms are root of x times ln of x, with this new trick here, I know I have to flip root of x down. So this limit will become the following: the limit as x goes to 0 plus of ln of x, that stays up, and you flip the root of x downstairs, and you get 1 over root of x. And now if you do replace x by 0, of course you still have the root of 0 and ln of 0, so you have to replace it by 0 plus. So what do you get now? Boom, you get ln of 0 over 1 over root of 0 plus. Here we need the root of 0 plus to be 0 plus, so you get minus infinity over 1 over 0 plus, which is minus infinity over infinity. Yay! I mean, it's still bad, but it's a bad quotient now, so we can apply hospital rules. So here we go. So we're applying the rules. So remember, you are allowed to differentiate above and below respectively. So the derivative of ln is 1 over x. The derivative of root of x, I already wrote it down for you. I will just write it on the side for you in case you need the details here. But so 1 over root of x is the same thing as as 1 over the 1 over x to the power 1/2, which is x to the power minus 1/2. So if you just use the regular power rule, you're going to get minus 1/2 x to the power minus 1/2 minus 1, which is minus 3/2. And if you clean this up a bit, you're going to get minus 1 over 2 x to the power 3/2. So you can now rewrite this as minus 1 over x over 2, x to the power 3/2. In these questions, it's very crucial that you simplify as much as you can. So if you simplify this just by flipping the two fractions, you're going to get the limit as x approaches 0 plus of 1 over x times 2 over x to the power 3/2 over minus 1. If you simplify the x's, you're going to get the limit as x approaches 0 plus. Of course, this would be a holy hole principle if you're really religious about precision here. So if you cancel terms, you're going to get minus, so I'll put the minus up, x to the power 3/2 with x to the power 1 simplifies to x to the power 1/2, which is a root of x. So you get minus 2 root of x. Of course, if you plug a 0, that's a bad root of 0, so you need to plug 0 minus. So you get 0 plus, you get minus 2. Root of x of 0 plus, which is 0, times minus 2, which is 0. So here, a lot of things going on here. Remember, I've plugged in 0 plus because I knew this was a root of 0 problem. Anyways, so if you have a bad product and one of the two terms is a logarithmic term, you never flip. You never flip. You never flip a logarithmic term. Always flip the other one. Then you're going to get a bad quotient. You apply hospital rule. Do some algebra. This is typically the challenging part for most of you. So do some algebra, simplify, reevaluate, or reapply the rule if needed. All right, so for that example, that's it. All right, next example is a bad difference, the infinity minus infinity. Compute the limit as x goes to infinity of x minus x times e to the power 1 over x. So again here, if you first try to simply replace x by infinity, you're going to get infinity minus infinity times e to the power of 1 over infinity. 1 over infinity is 0. E to the power 0 is 1. 1 times infinity is going to be infinity, so you get infinity minus infinity. I don't know if you are like me, but when I look at infinity minus infinity, I see the face of a sad robot, and it makes me sad. Very, very sad. Anyways, so infinity minus infinity. So for infinity minus infinity, what you have to do is the following. So you need to play, there's really no first algebraic step like a bad product where you have to flip one. Like for infinity minus of infinity, there's really nothing to say other than you need to simplify it somehow. Like if you find common factors, if you have like two fractions that you can combine. So you need to use whatever you know in algebra to simplify this expression. And if you manipulate this expression, typically what will happen is you will either go back to a bad product, which is still bad, but at least with a bad product, we know what we have to do. We need to flip one of the two terms. Or if you're lucky, sometimes you're going to get directly a 0 over 0 or an infinity over an infinity, and then you'll be able to apply Hospital rule. So let's go back to our example, knowing that, okay, we need to play with it. So if you have x minus x times e to the power 1 over x. So we have two terms, algebraically speaking, and these two terms, they have something in common. They have an x in common, so they used to date the same x. I'm so funny. Anyway, so I'm going to factor that x out. So this is the same as the limit as x goes to infinity of x multiplying 1 minus e to the power 1 over x. So now what happens if you replace x by infinity? So you're going to get infinity times 1 minus e to the power 1 over infinity. E to the power of 1 over infinity is e to the 0. So you're going to get infinity 1 minus e to the power 0, which is 1 minus 1. And 1 minus 1, whoa, is of course 0. And infinity times 0 is still bad. So we're still in deep S, okay, but bad product, what do? We flip one of the two terms. So between x and 1 minus ex, where it's two terms algebraically, the easiest one to bring downstairs is actually the x. So you bring your x downstairs. It's bad life advice here. So you bring your x downstairs at the denominator. So you get 1 minus e to the power 1 over x over 1 over x. And now what happens if you replace x by infinity again now? So if you replace x by infinity again, what you're going to get here is 1 minus, all right, oh, I have trouble here with my pen. Come on, okay, you're going to get 1 minus e to the power of 1 over infinity. Going to cut the crap here, but 1 over infinity, we already did this. It's 0. E to the 0 is 1. 1 minus 1 is 0. And down there, you're going to get 1 over infinity, which is 0. So now, yes, we have 0 over 0. Now we are ready, okay, for Hospital rule. So you apply your rule here. So you apply Hospital rule. So HR. So you get this brand new limit. The limit as x approaches infinity of, now you compute your derivative. Derivative of 1 is 0. Derivative of e to the power 1 over x is e to the power 1 over x. I'm using the chain rule times the inside derivative. The derivative of 1 over x is minus 1 over x squared. And then down there, what is the derivative of 1 over x? Oh, ho, ho. Again, it's 1 over minus 1 over x squared. Wow. So that's perfect cancellation here. This is like, feels very nice. It's very, very, very nice. So the 1 over x squared, the minus 1 over x squared cancels perfectly the minus 1 over x squared. Now you replace x by infinity again. So you're going to get minus e to the power 1 over infinity. E to the power of infinity, 1 over infinity is 0. E to the 0 is 1. And you just get minus 1. So here, so we have to use more tricks. There's really no specific path to follow other than play with your expression. Try to make it into a bad product, or even better, try to make it into a bad quotient. And as soon as you get your bad quotient, then you can apply hospital rule. All right, so for bad product and bad difference, infinity minus infinity, that's it. That's all. Bye-bye.